Welcome to Asim Code. Want to learn more? Like and subscribe to stay in the loop for all things coding and development. Quicksort is a highly efficient sorting algorithm that follows the divide and conquer strategy. It works by selecting a pivot element from the array and partitioning the array into two subarrays 0. One with elements smaller than the pivot and the other with elements greater. The pivot is then placed in its correct position. This process is recursively repeated for each subarray. The key operations in Quicksort include selecting the pivot, partitioning the array around the pivot, and recursively sorting the subarrays. The algorithm has an average time complexity of O and log n, but in the worst case, it can degrade to O na superscript 2 if the pivot selection is poor. Despite this, it is still widely used due to its simplicity and efficiency in practice, especially when paired with good pivot selection strategies. Function to perform the partitioning of the array. This function divides the array into two parts around a pivot element. Elements smaller than the pivot are placed on the left side, and elements larger are placed on the right side. After this process, the pivot element is in its correct sorted position, and we return its index. ARR is an array of integers that we are sorting. Low and high are integers representing the start and end indices of the subarray being worked on. The pivot element is selected as the last element in the subarray. We use the last element of the subarray for simplicity. There are other strategies for pivot selection, but this is one of the easiest to implement. I keeps track of the boundary of the smaller elements. Initially, we set I to 1 less than the low index. This allows us to move I to the correct position when we find an element smaller than the pivot. I is used to track the position of the last element smaller than the pivot. Loop through the array, excluding the pivot, to compare each element with the pivot. J iterates through each element in the subarray. If the current element ARR, J, is smaller than or equal to the pivot, we need to move it to the left side. Increment I because we are going to move an element smaller than the pivot into the left part of the array. Swap ARRI and ARRJ. This ensures that all elements smaller than or equal to the pivot are moved to the left of it. Temp is used to temporarily store the value of ARRI during the swap. After finishing the loop, I will be the index of the last element smaller than the pivot. Now we need to place the pivot in its correct sorted position by swapping it with ARR, I+1. This ensures that the pivot element is placed at the correct position where all elements to the left are smaller, and all elements to the right are larger than the pivot. Temp temporarily stores ARR, I+1. Move the pivot to its correct sorted position at index I+1. Put the original pivot element in its correct sorted position. Return the index of the pivot element after partitioning. This is the key index that divides the array into two parts. Return the index where the pivot element is now located. Quicksort function. This function sorts the array by recursively partitioning it into smaller subarrays and sorting each subarray. It follows the divide and conquer approach. Base case: if the subarray has one or no elements, it is already sorted. If low is greater than or equal to high, the subarray contains 1 or 0 elements, so no sorting is needed. Partition the array around a pivot and find the index of the pivot. The pivot is placed at the correct sorted position. Pi is the index of the pivot after partitioning. Recursively sort the left subarray, from low to pi 1. The left subarray is the part before the pivot. Recursively sort the left subarray. Recursively sort the right subarray, from pi plus 1 to high. The right subarray is the part after the pivot. Function to print the array, used for visualization of the sorting process. ARR is the array, and size is the number of elements in the array. This function prints the elements of the array, separated by spaces. Loop through all elements in the array. Print each element followed by a space. Print a new line after the array is printed. Define an array of integers that we want to sort using the Quicksort algorithm. N is used to store the size of the array. The expression size of ARR/size of ARR0 gives the number of elements in the array. Size of ARR gives the total size of the array in bytes, and size of ARR0 gives the size of a single element in the array. Print the original unsorted array. Perform the sorting using the Quicksort algorithm. The Quicksort function is called with the array, with low set to 0, the start of the array, and high set to n1, the last index of the array. Sort the entire array from index 0 to n1. Print the sorted array after applying Quicksort. Call the printArray function to print the sorted array. Return 0 to indicate that the program finished successfully. Now run our code. If you're into coding, and I hope you are, make sure to give this video a like and subscribe to the channel. It's super simple, and it helps me bring you more tutorials, fun coding challenges, and tech tips. Plus, you'll get notified every time something new goes up, so you won't miss a thing. Go ahead, click those buttons. I'll wait.